Hello, now we are going to look at creating and using formulae. So a formula is kind of like an equation. And we'll look at one that is given to us first and how it is we can substitute into them and rearrange them, and then we'll look at creating some of them. So the distance of a ball from the ground. So if we have a ball and we throw it up with our hand, we throw it up in the air, straight up in the air, this is a formula we can use for figuring out how far it has traveled after a particular amount of time at a particular acceleration. So S is going to be distance, technically displacement. U is how fast you start throwing it out with your hand. T is the amount of time, and A is the acceleration, how quickly we are changing our speed. Now, what's important here is simply that we can recognize the information that we are given and sub in to find the distance at the particular point that we're told about using our formula. So we have S is what we are looking for, U is 20 meters a second, T is 4 seconds, and A is minus 10 meters per second squared. So the first thing to double check if we're given a more complicated story is, are all of our units the same? So this is meters per second, this is seconds, this is meters per second squared. So everything is in meters and seconds. Well, that tells me that my distance is eventually going to have the units of meters, because that's the type of units I'm dealing with. If I was told about kilometers per hour and seconds, I'd have to convert everything to meters per second, so I had everything in the same type of units. That's something to watch out for a question like this. But here we have all the right units, so we sub in, and everything goes in brackets, and then we're just careful with our calculator work. So U is 20 meters per second, T is 4, plus a half multiplied by A is minus 10, so we have to be careful of our minus numbers, times 4 squared, everything in brackets, and the only thing that's squared here is the 4. So this means a half multiplied by minus 10 multiplied by 4 by 4. So the squared is just on the 4. Then we sub into our calculator, do it in different pieces so it's easy to see if an error comes about. So we have a half multiplied by minus 10 multiplied by 4 by 4, and we end up with minus 80. So we end up with 80 minus 80 is 0 meters. Now, just in terms of an exam question like this, what would that mean? Well, that means that we threw the ball up in the air, and obviously it had a distance away from our hand, and then when it falls back down and we catch it again, the distance from us is gone down to 0 as well. So that is the meaning of the fact that we got a 0 distance here. The ball has come back down to where it started. Now, if we were asked a question where we were going to write A in terms of S, T, and U, or the other way that could be said is make A the subject. So at the moment, S is the subject, or S is written in terms of U, T, and A. Now we want to rearrange it so A is by itself and equal to everything else. So we start out with what we know. We know S is equal to UT plus a half AT squared. And we know that we want to end up with A by itself. Well, I can rearrange this the same way as I would rearrange any equation, just so that I end up with A by itself. So I don't want this UT here. I'm going to subtract UTs from both sides, so I have the stuff involving A all together by itself. We'll do a half AT squared. Now I don't want to have this half here, so I'm going to multiply both sides by 2, because 2 divided by 2 is going to leave me with 1, so I'll have AT squared, which is neater. And to keep the balance, I must do the same thing on the other side. So I have 2S minus 2UT is equal to AT squared. And now I want to divide both sides by T squared, so I just have A. T squared divided by T squared is 1, so I'm left with 1A on the right-hand side. So when I've done that, I have 2S minus 2UT all over T squared is equal to A. So I now have A in terms of everything else, or I have A made the subject of the equation, or the subject of the formula. So if we were asked to describe the acceleration which is our a in this formula, we would be able to rearrange everything else so we had a is equal to everything else, so we would be able to see what the acceleration was doing more clearly. Now, here we need to create an equation. So a rectangle is twice as long as it is wide, and its area is the same as its perimeter. If that is true, find the length and width of the rectangle. Well, if I'm told I'm dealing with a rectangle, the very first thing I'm going to do is draw a rectangle. I'm going to draw a rectangle. It does not need to have a ruler or anything with it. This is simply to help us think through the information we're given. So we have a rectangle, and it's twice as long as it is wide. Well, that means if I had a particular width, the length would be twice the width. So it is twice as long as it is wide. So if I have a particular width, the length is twice that. And I fill in the rest of the information so I know everything. So I now have all the sides of my rectangle filled in, and that's pretty much what we need for a rectangle in terms of finding out information. And now what else are we told? We're told that the area is the same as the perimeter. So the area is the same as the perimeter. Well, I know what the area of a rectangle is. That's length by width. And I know that the perimeter is length plus width plus length plus width. So what I have to be able to do in a question like this is say, I'm talking about a rectangle, so I draw a rectangle. I'm told its length is twice its width. I draw that in on my diagram. Then I'm told that the area, or something about the area and the perimeter, so I write down the area and the perimeter. I write down what those things are. And I'm also going to write down what I'm told, that they are the same. So that means they are equal to each other. If things are the same, they are equal to each other. So what I've done is I've taken this big block of English and I've translated it into a picture, and I've written in the information that it gave me in the big block of English, and I've written down any formulas that are connected to what they're talking about. And that's how I now piece together the steps I need to take, because I can now write down an equation where A is equal to P. The area is equal to the perimeter. But if I just write it down right now, L multiplied by W is equal to, I have like terms here, 2L plus 2W. I don't have enough information to solve this type of equation, because I only have one equation. Well, I almost have only one equation, and I have two unknowns. So if I have two unknowns, I'd need two equations. But if I look at my original diagram, I can see I actually have a second equation. There's something else I know. I know the equation that L is equal to 2W. So now I've got simultaneous equations, and I can do this via substitution. So I know that L is equal to 2W. So anywhere there's an L in this formula, I could sub in 2W, and that would be true for this rectangle. And then I'll have an equation only in W that I will be able to solve. So that is how we write out all the information we're given, and then we can make progress with the question. But I did not need to be able to know that I was going to do this substitution, that L was equal to 2W, and put it into this formula. All I needed to do was write down all of the information I was given and draw myself a diagram if I can. And that's how we get ourselves unstuck in questions like this. So we multiply this out, 4W plus 2W. So 2W is equal to, I have like terms here, 6W. And I can see that I now have a quadratic, so I'm going to gather all of my terms on the left-hand side, make everything equal to 0, would be another way of putting that. So 2W squared minus 6W is equal to 0. Now, I don't have a constant term, so what I can do here is just try to take my highest common factor. That's the first type of factorization we should always do. And I can see the highest common factor of the numbers is 2, and the highest common factor of the letters is W. So that means that I have 2W on W minus 3. If I multiply out that bracket, I have to get back up to this line. So 2W times W gives me 2W squared. 2W times minus 3 gives me minus 6W. So I've done my factorization correctly. Now I have two variable things multiplied together equals 0. Well, that means that they could independently be equal to 0. So if twice a number is 0, well, that means that W must just be equal to 0. That would be a possible solution. And here, W minus 3 is equal to 0. So W could be equal to 3. Now, the width being 0 doesn't make any physical sense. This is supposed to be the width of a rectangle. So I can dismiss this answer. I can say that that doesn't make physical sense. But the width being 3 would be perfectly fine. So I know then that my width is going to be 3. And I know that my length is equal to twice my width. So my length is going to be 6. Now I don't know what my units are for this question. Sorry, I should put in 2 by 3. So I'm just going to put in units. So that was what I was asked for, length and width. Now, a more complicated piece of translation. An electricity bill has a standing charge of €20. That means we have to pay €20 regardless of how much electricity we use. And each unit of electricity costs €3. VAT is charged at 20%. Find the VAT in euro. So this actually means find the formula for the VAT in euro. So the VAT is going to be 20% of our bill before VAT. So let's write that down. Our VAT in euro, our euro VAT, is going to be 20% of our bill before VAT. So we have 20% of our bill before VAT, and we know that 20% is 20 out of 100, which is 1/5. So 1/5 of our bill before VAT is the amount of euro VAT we have to pay. So we've told ourselves the story. Now how do we get the bill before VAT? Well, it's €20 plus €3 for every unit of electricity we use. So that's going to be 1/5 for our 20% of, we have €20 that we definitely have to pay. We also have €3 for each unit of electricity we use. So our bill before VAT is €20 plus €3 for each unit of electricity we use, and the VAT is going to be 1/5 of that. So we've now told ourselves the story of that. You can actually multiply this out. The euro VAT is going to be, multiply each of these by 1/5, and you end up with 3u/5 plus 1/5 of 20 is 4. So the key part here is this step. We know the VAT is 20% of our bill before VAT gets charged, and we know that that's going to be €3 for each unit plus €20 is our standing charge that we have to pay regardless of how much electricity we use. So now we've got our story, we've now got our formula. If 100 units were used, if 100 units of electricity were used, how much VAT would we have to pay? Well, we now have a formula for that, so let's sub in. So we sub in our 100 units of electricity. We pay €3 for each one of them, and we know we're getting 1/5. So we sub in, and carefully, step by step, we work out our euro VAT would be €64. We'd have to pay €64 in VAT if we used 100 units of electricity. And if the euro VAT cost us €40, so if we had to pay €40 in VAT, how many units of electricity did we use? Well, we write down what we know, that our VAT equals €40, and now we need to isolate U in order to find the number of units. So when we rearrange, we will get it, we used 60 units. So that's what we need for creating and using our formula.